So hello everyone, my name is Sena. I'm a PhD student at McGill University, and today I will be presenting my study titled as Coins, Cards or Apps, Impact of Payment Methods on Street Parking, Occupancy and Search Time. This is a joint work with my supervisors, Professor Mehmet Gümüş and Veichi, and we submitted this paper to Production and Operations Management, and it's under minor revision right now. So let's start with the motivation of our study. Actually, as evident from these newspaper articles, we know that urban planning is a common struggle for drivers from all over the world. And whether it's circling the block, search for a parking, right? Whether it's circling the block in search of a parking or experiencing delays because of the cars doing the same thing, we know that street parking significantly affects people's daily lives. For example, here, one of the drivers says that he is being late frequently to his work because of the time that he spends while looking for the parking space. And another driver constantly avoids using her car because of the difficulty of finding a parking place on certain days. So in fact, actually in the literature, it was shown that drivers spend 3 to 14 minutes of their time while only looking for a parking space. And this surge of a parking actually contributes 8% to 74% of traffic. And not only that, also not being able to find a parking place in their intended street amplifies the hassle of drivers because of the extended walk, because they need to walk from their parking space to their destination at the end. And with the anticipation that most of the population will start living in urban areas, actually we believe that these issues will be more problematic. That's why we thought that municipalities first needs to understand the driver's behavior so that they can overcome these issues, and also they can provide as many street parking as possible in different streets. So it is believed that the heart of parking problems actually lies in the fact that street parking is either free or underpriced. And they believe that this underpricing actually encourages drivers so that and they will contribute to traffic and also pollution at the end. And also some argue that maybe we can increase the price so that we can discourage people to use their cars, and maybe they can use another form of transportation. However, simply increasing the prices might not be the ultimate solution, because it might be seen as a financial burden for some drivers, especially for those who actually rely on their cars for their daily commutes. And also, increasing prices actually disproportionately impacts the lower income residents, which might not actually decrease the parking demand at the end. So our study comes into picture at this point. My dissertation actually consists of 3 studies. In the first two, we try to understand the behavior of drivers. And in the last one, our aim is to optimize parking through parking strategies. And today, as I said, I will focus on the impact of payment methods on street parking, occupancy, and search time. So in order to show you the decision-making process of drivers, assume that we have a driver in a red car with the destination shown here. After finding a parking place nearby their parking spaces, actually, drivers need to decide how much to pay. While deciding this, they need to consider the parking price, and also they need to decide their anticipated needs. However, determining the payment amount is difficult for drivers because they cannot estimate their parking need beforehand accurately. Not only that, they also need to decide how to pay. Why is it an issue? Because in the literature, it was shown that payment methods actually change drivers' behavior. Not the driver, sorry, but consumers' behavior. And here, we have a box plot of our transaction data collected from our partner organization. And actually here, we can see just descriptively that we have differences between the means of different payment methods. Here, for example, green box corresponds to cash payments, it seems that even though they have the inconvenience of not being able to increase their payments remotely, actually cash payers tend to pay less because they might be aware of their payments. And this phenomenon is actually called pain of payment in the literature. And it is more in the cash payment because of the physical availability of the money. And here, the blue box corresponds to mobile payments, and the red one finally corresponds to credit cards. And as you can see, we have slight difference between the mean of these two payment methods. Here, we believe that this is because of the convenience of mobile payments, because mobile applications allow drivers to increase their payments remotely. And that's why they don't need to pay more upfront to diminish the hassle, actually. So considering this, we looked for the street parking research, and we saw that although we have lots of studies in, for example, for price elasticity, parking availability, and parking duration, these studies constantly overlook the differences that might come from payment methods. That's why our study focused on that point. And here we have 3 research questions at this point. In the first two, actually, we look for the effect of payment method, price, and their interaction on the payment amount. And in the last one, we try to see the impact of price change and payment methods on the occupancy and search time. So if we go back to the decision-making process of drivers, after finding a parking place, drivers need to use the payment machines nearby the parking locations, and by these machines, they need to use cash or credit cards, or they may use their mobile applications. And we know that in most of the cities, actually drivers need to pay in advance. So, but uncertainty in the parking demand actually poses a challenge similar to the Mies-van problem. And here drivers face with overpayment and underpayment trade-off. So in the context of street parking, actually, when we think about it, if drivers pay more than what they need, they will lose money depending on the parking price, and it will be considered differently because across different payment methods because of the concept called pain of payment. And in our transaction that I will explain later, our parking price is the same across different payment methods, but it will change depending on the region of the city. And on the other hand, we have the underpayment issue. In this case, if drivers pay less than what they need, they risk themselves being getting fined from the enforcers. And then in order to avoid this, actually, they need to take a break from their activities and go back to their cars. Or they need to increase their payments, maybe using mobile phones or using the machines again nearby their cars. So for example, here, again, the hassle will be different depending on the payment method. For example, because cash payers need to carry change, and they need to adjust their payments accordingly, and they act according to their payments actually afterwards. However, for example, mobile payers has the ability to extend their payments remotely. That's why they, if they notice that they need to stay longer, they can increase their payments easily. So to tackle this uncertainty, actually, we thought that we can use the Mies-van approach. And using this approach, actually, we define the optimal payment amount by defining the underpayment and overpayment. Here again, overpayment defined as the interaction between the price and the pain of payment, sorry. And the underpayment defined as the minimum of expected ticket price and the hassle cost. So by analyzing the critical ratio, actually, we created 3 sets of hypotheses. In the first one, we compared the payment methods, the difference between the payment methods on the payment amount. And then we checked the effect of price, again, on the payment amount. And in the last set of hypotheses, we checked the response to price change across payment methods. So in this study, actually, we used 2 sets of data. In order to answer our question about the interaction between payment method and price, we use the transaction data collected from our partner organization. And in order to check the main effect of the payment amount, payment methods sorry, we use the survey that we created and conducted. So starting with transaction data, data actually spans for different periods before and after COVID. And it includes payment amount, parking spot name, start date and time of parking, and payment amount. If you look at the whole data, actually, you're familiar with this graph. We can see that we have different, we have street parking in different part of the city. And as I said, different regions have different prices. So as you can imagine, as in all, almost every empirical analysis, we don't have every variables that will affect the payment amount. That's why, in order to avoid the omitted variable bias, we look for discontinuity in price in this region. And luckily, we found an exogenous shock impact in this region. And if we look closer, we can see that these parking spots actually separated only by a road. And parking spots nearby these boundaries actually very similar to each other in all aspects but the price. And we can see that there is a $1 difference between the parking spots located above or below the road separating these streets. So then we thought that, okay, by using the transaction data from this region, instead of using the whole data, we can eliminate the omitted variable bias as much as possible. And that's why we use regression discontinuity model in this region. And when we talk about regression discontinuity, actually, we are familiar with these graphs. Without sophisticated models, we can see that we have difference between the payment, the price will change the payment amount. And also we can see that payment methods actually, drivers choosing different payment methods actually act differently depending on the price change. So in order to empirically test these differences, actually we use survival analysis. And we construct a regression discontinuity model. And following our analytical model, actually, we use treated I as the independent variable for price. And it is one if the parking place I is located in the region with lower parking fee and zero otherwise. And we also have payment methods, and also we have the interaction between price and payment methods to see the effect. And as I need to note here that since we have the regression discontinuity mechanism introduce a shock in parking price, but not in payment methods, we use the payment method as a moderator in our analysis. We don't make any comments about the main effects of payment method using this model or the transaction data. So our empirical analysis showed that decrease in the parking price by $1 actually significantly increases the payment amount. And this increase is actually 16% for credit card payers. And we saw that compared to credit card payment, the impact of treatment is most pronounced under cash payment, it's 34% increase. And it's second most under the mobile payment, it's 24% increase if the price decreases by $1. Which actually amplifies the interaction between the payment methods and the price. Yes.
I have a question. Maybe I did not understand. So you are saying that you did treatment on one side of the road, right?
Yes.
So can you make sure that people did not? It means people who were parking on the other side of the road start parking on the.
Yeah, actually, we have a graph for that on the appendix. I can show you after the presentation. We checked the robustness of we checked the validity of the regression discontinuity, and we showed that we don't have high peaks the other side of the city. So as you can see, actually, we have the payment method on our transaction data, but to avoid the endogeneity problems, we created a survey. And in this survey, we tried to understand the decision-making process of drivers, actually, in this case, participants, to using different parking scenarios. And the survey uses 3 payment methods and 2 price as between subjects. And then we follow the literature on the factors affecting the parking behavior of drivers. And we use distance to parking. sorry, distance to destination, reason of parking, and duration of parking as the between subject design factors. And then we assign participant to one of the 6 between subject conditions. Then we ask only 4 within subject questions instead of using full factorial design, and we created these 4 questions using L4 orthogonal array of Taguchi design. And lastly, to achieve reasonable statistical power, actually we recruited more than 300 participants, but 64 of them failed attention check. That's why we only used 278 of our participants in the analysis.
Sena,
yes.
Maybe a quick question. Why did you use between subject method or between subject method?
We actually here we use mixed design. We have between subject to tackle with to actually check the main effects of payment method and price. And we also use others as within subject to consider different factors affecting the behavior of drivers. So with the mix ANOVA, where the dependent variable is actual payment duration or the payment amount, we showed that the main effects were significant for payment method, average parking duration, and distance. Specifically, post-hoc analysis showed that participants assigned to payment method, mobile payment condition, actually pay approximately 4 minutes less than the cash payers and 4.5 minutes less than the credit card payers. And even though we have mean difference between the cash and credit card condition, we didn't see a significant difference between these two. Actually, this shows that participants see these payment methods as equal because of the hassle of not being able to increase their payments remotely. So what we observed from our study actually, the most important finding is that mobile payments lead to shorter parking duration, which has significant managerial insights. Since they will pay shorter parking duration, it will improve the turnover rate, and eventually it will reduce the parking search time. And also we showed the interaction between price and payment methods and influences parking behavior. Why it is important? Because it's vital to make the change depending on the region by considering the user behavior and demographics. For example, we can say that municipalities maybe increase prices in business districts without changing the demand significantly, because in these districts, people tend to use credit cards compared to the other regions with a high percentage of older generations. Or if we increase the price in university areas, we may reduce parking demand due to the higher sensitivity, because younger generations tend to use mobile applications, and I showed that mobile payers actually more sensitive than credit card payers. So to sum up, until now, I showed that payment method and price actually changed the payment amount of drivers, and eventually we are saying that it will change the occupancy and search time, but we don't know how. So that's why we created a set of discrete event simulations, and we tried to see the impact of pricing policy and implementation of mobile applications. And we use 10 street set, in total 91 streets with different capacities in this simulation study. So for the sake of time, I will skip the details of the simulation, but I want to say that we do the robustness test, and our results actually robust to our parameters in the simulation. So our first objective is actually to check the effect of constant pricing. To do so, we increase and decrease the price by $1. And the most important finding is that actually when we decrease or increase the price, we have an asymmetric result, change, sorry. If we decrease the price, for example, we can see that the search time increases 3.5 minutes, whereas if we increase the price by the same amount, we can only decrease the search time by 1.9 minutes. And also, we saw that the impact is higher in the mid occupancy areas, And we can say that we have a sweet spot where the effect actually peaks before diminishing. So we can see the same thing actually in the average occupancy, under the average occupancy. We can see that in the mid areas, we have higher change in the occupancy with the decreased price compared to the increased price by the same amount. So actually, since drivers act differently to price change, as we can see, we thought that maybe municipalities might benefit from using progressive pricing instead of constant pricing. And to check the effect, actually, we created two different scenarios. In the first one, we used decreased price during the first 60 minutes of parking, then increase the price for the rest of the parking duration. We called it low then high pricing, and we have the high then low pricing as well. So again, we have this sweet spot, and we can see that the effect will not be the same across all the streets. And here with low then high pricing, compared to constant low pricing, we can change the surge time by 1.5 minutes, and we can change the occupancy by up to 2%. And also we have the same observation under high and low pricing. This actually shows that these findings actually show that the importance of data-driven policies compared to constant pricing policy for municipalities to manage the parking better. So what we observed, actually, we can say that by using different pricing policies in different parts of the cities, municipalities can ensure more efficient use of parking resources, improve occupancy rates, and reduce surge time. If we check for the three pricing policies, for example, we can say that constant pricing is simple and predictable for everyone, for both the drivers and for municipalities. It's easy to implement, and it ensures stable turnover and manageable surge time, as we can see with the increase and decrease the price. So we say that a constant pricing might be ideal for residential neighborhoods with moderate demand. However, low and high pricing encourages shorter parking duration and ensures higher turnover. That's why it would be ideal to use them for high demand areas like downtown streets. And lastly, high and low pricing discourages short-term parking, but we can still benefit from the high initial prices if people want to stay shorter periods. That's why we thought it might be suitable for locations like park and ride or airport parking lots. And lastly, actually, we wanted to check the impact of mobile payment implication. That's why we, again, created two distinct simulations. In the first one, we only use cash and credit card payments. We don't have any mobile payments in the first scenario. And in the second scenario, we exclusively incorporated mobile payments. And when we check the result, again, we see that the result will change depending on the average occupancy of the streets. That's why we cannot expect to have the same result from every street of the city. And the implementation of mobile application can actually lead to a decrease in occupancy by up to 3.9% in medium occupancy areas. And we can reduce the surge time by up to 1 minute without needing to change anything else. By just implementing mobile application, we can reduce the surge time without even using pricing policies.
Sena, before we move on, can you explain why you get this 3.9%? What's the rationale? What are the factors that really?
So previously we observed that mobile payers actually tend to pay less than the others. So here, in our second scenario, we changed every cash and credit card arrivals to mobile payments. We shift their payments according to our findings from from survey and from transaction data. That's why we know that they will pay shorter periods, and it will increase the turnover. And even though we have new arrivals, we know that they will stay shorter than compared to other periods. That's why we have a decrease in the occupancy in overall. Does it answer your question?
Yeah, when they actually they pay shorter, you are not saying that they kind of reduce their time, that they spend in whatever in their meetings. It's just that they are now predicting their time much better with the mobile. So instead of like paying extra.
Yes, instead of paying overpay,
yes,
they pay, maybe they can pay less than what they need at the beginning, but they can adjust, they know that they can adjust their payments. That's why they actually tend to pay less overpay, make less overpayments. So we can say that actually at the end, mobile payments improve parking efficiency, reduce search times, and enhance turnover. But with the, as in every implementation, we can see challenges while implementing mobile applications. That's why we suggest municipalities to focus on early adopters to identify and resolve issues before broader expansion to whole city. And after dealing with these issues, maybe they can prioritize high demand urban areas to get the most immediate impact from the mobile applications. So in summary, in this study, we focused on the payment options, payment methods, and price adjustment in payment amount, search time, and occupancy levels. And we showed significant results for policymakers and urban planners. We showed that increasing and decreasing the price will change the, will have an asymmetric effect of on the payment amount, sorry. And we identified a sweet spot, meaning that we cannot expect to have the same result from every street. Maybe we can prioritize some street for the implementation of different parking policies. And we lastly showed the benefit of implementing mobile payment option. And for the future research, actually, in this study, we only focused on $1 change because of the nature of our data. Maybe one can enhance the study by using different price increments or decrements. And also in this study, since we cannot observe the change in the arrival rate based on the price, we couldn't touch on the revenue implications. And lastly, actually, in our simulation study, we used random search for the drivers. Maybe in order to reflect real life more accurately, we can change the search pattern of drivers. So thank you for listening. Here's the QR code for my paper if you want to check. If you have any question, I will be glad to answer.